Prospects that there has been life on Mars and yet may still be life on Mars has just shot way up based on a couple of findings that NASA and various researchers have found. My friends, it is getting really interesting for the prospects of life in space. I'm Greg Allison with Galactic Greg's here. Please subscribe, bang the bell, and click all to get more updates here. My friends, we're going to go into this. I'm going to show you these articles. I'm going to show you why it matters and what it could be. So give me a second here. Pull up the right screen. All righty. So what happened here is they had this uh, InSight probe on Mars that was measuring seismic data from Mars, and based on that and gravitational studies, some researchers have determined that there's perhaps a little liquid ocean inside the crust of Mars. I kid you not. And that's not really so far off, because now we believe that there's actually more water inside between the crust and the mantle, down in the mantle region of Earth, than there is in our oceans. So apparently water likes to sink, find its way down the cracks and whatever. So we know and we believe that Mars had oceans once upon a time. The idea that some of that water would have slipped below is not at all outside the realm of possibility. And now they seem like they may have detected it. So what this boils down to is this researcher named let's see here, Jakowski. He made these discoveries using analysis tools, and what he said is that the approach and analysis are reasonable and approximate, but the results of the modeling suggest there could be an alternate conclusion too. So they're not entirely on this. But what he said here is addressing the proceedings of the National Academy of Sciences was that there looked like there was a sustainable liquid water at the mid crust, and this is based on this. He worked on Maven earlier, by the way. So the study in question was based on data collected by NASA's InSight mission, and what they found was that between 11.5 and 20 kilometers below the surface. So that's quite a few kilometers. We're talking about, 8.5 kilometer thick region that may have water immersed within the rocks. So, and what they're finding here is that the models they found match that. So, but he says there's other possibilities here. He says we expect there to be water or ice in the crust. He's actually detecting it's a possibility. Determining the amount is challenging but extremely important. But he's also pointed out that this could be just the porosity of the rock. There could be other explanations he suggested here, because that's what you got to do. You got to kind of discount everything, especially such big claims as this. So this article seems to be more about discounting it than counting it. Now, it's kind of funny. You get this article here showing up in Mars Daily, but you got to go to a more off the wall chart or website to find something that might actually better match, something the layman would understand. I got to move this screen because my Zoom is laying over my tabs here, way low, a lot more lower than normal. Okay. New seismic clues, and coast to coast, of course, hint at the possibility of life on Mars. Now, see here, they put it all out real clear, as to what's going to be put in layman's terms. 10 to 20 kilometers beneath the surface. Researchers Abo, Katamar, Katamia, I can't even say it, and yeah, there's just two researchers here that was fine. It was a French experiment. Oh, no, this wasn't French experiment. That's another one. Anyway, so this is their analysis. Yeah, I'm going to pull up this other one here. This other finding. What they're talking about now is they've also found long chain molecules on Mars, hydrocarbons. Now, this was from a French instrument called SAM on board the Curiosity rover. And these chains may be 3.7 billion years old. Well, we know out in the elements, these chains would tend to break down, UV and stuff like that. So they could have been more complex in the past. So these scientists are from CRNS, And so this French tool on board the Curiosity rover, known as SAM, which stands for Sample Analysis at Mars. Nice that the French would use American acronyms. Here's where they drilled the hole and found this stuff not too deep down. So, and they're looking forward to maybe finding the stuff and Titan in other worlds. So, well, let's talk about what does it mean to have life in rock. It sounds, oh, great, there's no photosynthesis. How would you have life? Well, it turns out on Earth, they believe the predominance of the microorganisms actually live down in the crust and, at the edge of the mantle and that water region we've got below, basically rock. So a thin layer known as Earth's crust contains an even thinner layer that is suitable for sustaining life. The boundary conditions that define where we can have life, it's a range of temperatures in liquid water. So the prevailing rather extreme conditions in the deep subsurface dictate that it is mainly inhabited by prokaryotic microorganisms, whatever that means, but it's a class of organisms that don't require sunlight. They're actually using the rocks themselves as nutrients. But we're finding that there's quite a bit of life in the rock deep under the surface of the Earth. Now, let's see. And this article says, this is what I want to point out. In fact, most of Earth's microbial biomass is dwelling in the deep subsurface. Now, see, this means if there was ever life on Mars and there is water deep down, it can still be there, both water and life. That's what that boils down to. And this is another paper talking about the crust underneath the ocean. Since 7/10 of the Earth's surface is covered by water, well, there's crust under the water, and they've done analysis, and they're finding very complex microbial communities in some of these areas they're researching. This is the Nankaya Trough sediments, where they've pulled this stuff up, I guess, with core samples. And here they're finding things that are interesting. Although the metabolic processes in the deep and subsurface have been estimated, microorganisms remain largely unidentified. So there's a whole community of them. That's what they're saying in this article. I'm not going to read the article. That's probably would be infringement on copyrights. But another article, subsurface microorganisms work together for common good. So they got their own ecosystem. That's what it boils down to. They have their own balanced ecology in the rock. And now, just to bring it a little deeper, microorganisms found alive, sealed inside a rock for over 2 billion years. I guess this is a rock they did not think they would find anything in the end. They break it open, and it's got microbes in there that's been in there for 2 billion years, according to this article in earth.com. Well, friends, this is interesting. How much longer could life sustain itself in rocks, clay sealed microenvironments? They said this rock was sealed. So nothing was getting in or out according to them. Now, I don't know, microbes, life finds a way, right? And maybe that's the real answer. Life finds a way. But maybe there's other places on Mars, some cave on Mars, apparently. Maybe the picture don't look like this article, but in any event, we're in interesting times, to say the least. And not only that, they're even saying we may have life on the moon. Now, that's the crazy one. And what they're talking about here is what we said, it's low chance, but not zero. We'll talk about that in a minute. So what they're talking about here is the permanently shattered regions of the moon. They call them PSRs on here. This came out of the Planetary Science Conference last month. And so what they're saying is that the areas in the permanently shattered craters where you've got volatile materials and water ice, and along the edges, some of that ice would tend to melt from time to time, and it's possible there'd be life there. He said here that, to be clear, those microbes cannot metabolize, replicate, or grow here, but they could remain viable for decades until the spores are killed by the effects of vacuum. Now, what if they're underneath the surface and not directly exposed to the vacuum? And what if they're like the microbes on Earth that actually know how to munch rock? I don't know, my friends. It's getting really really strange here. So I'm going to stop the share and we'll talk about it for a minute. So life appeared on Earth almost as soon as the volcanic rock cooled enough to preserve a fossil. I mean, it was almost instantaneously, which is really interesting because just by random chance, getting any one of the many proteins that's responsible, folded correctly, that's responsible for living organisms from random processes would take eons. Uh, you may be aware that there's these little things that work their way alongside the structures inside cells that move proteins and enzymes and such back and forth as they track real slowly from one side to the other inside a cell. Somebody calculated the probability of this kind of thing occurring on a random basis. It would be that like you would have to have one of these little slow moving things inside the cell capable of moving across the entire length of the universe 80 times before you'd get even on a world as a water world, a whole planet of water. So it might be the life inception process is extremely complex. So how did it arise? How did it arise so fast? One answer may be panspermia. And the idea is that, inside if an asteroid hits the Earth, some of Earth's crust gets knocked off. Well, these rocks that get knocked off have life in them. Well, the entire interior of the rock doesn't heat up like the outside. There may be regions inside these rocks where this life could survive. And there's been studies, Richard Hoover, I did a video on real early in this channel, talked about the prospects of life from space via panspermia. And the whole idea is that life was seeded from the stars, basically, the panspermia. And it's kind of an intentional creation type story, too. It kind of ties into that intended design for life. And maybe, and funny thing is, on life, they say that all life has a common ancestor. Well, it's got the common code. It's got the same spiral to the proteins, to the amino acids. And so it's ubiquitous through all life on Earth. But maybe, here's the funny thing, is Earth ever 250 million years, goes all the way around the Milky Way galaxy with the sun. So Earth life would have seeded the entire galaxy by panspermia, just life from Earth, if that's the case. And probably so life from Earth would have the opportunity to live elsewhere. But Earth is not by far the oldest rocky planet in the Milky Way galaxy, not by a long shot. So maybe other planets going around are doing the same things, and maybe that's how life showed up here so fast. But this suggests it may all be related. Or elsewise, over all the trips around the Milky Way galaxy, we should have picked up a lot of other things, and something else might have had opportunity to ignite, to live, to grow, unless our life was so predominant it just didn't get a foothold, which seems kind of odd. So, what does this mean? Are we all kin? Is everything in the Milky Way galaxy related? Is this the only galaxy that's got life? Probably not. Probably not. And so I do believe in a greater creator, my friends. A lot of you don't subscribe to that. I can go into that more in the future. But I do follow the notion of intelligent design. So I think this is all very, very interesting. But panspermia would suggest that life from Earth could have inoculated Mars and the Moon, or maybe life from Mars started life on Earth, or somewhere else out there. I don't know, friends, a lot to ponder, but it's just fun stuff to kick around, fun stuff to think about, to ponder, as I said. So you tell me, what do you think? Leave your comments below. We're going to have a lot more findings real fast, I'm thinking. And if we can survive all the wars we're on the verge of, we're going to live in interesting times. So again, please subscribe, bang the bell, and click all. And then I'm going to say thank you for watching. Greg out.